Hi, and welcome back to Alpha Cloud. So in this video, I am going to talk about Terraform Cloud, how one can use Terraform Cloud and deploy Terraform Cloud agents. So basically, we can set up the agents, our own machines into Terraform Cloud via the AWS Cloud, and we can use these agents to deploy resources in multiple AWS accounts. So let's just quickly check the Terraform Cloud interface. So this is the Terraform Cloud pricing for their multiple tiers. They have free, standard, plus, and enterprise. You can use free tier, and they have this resource limit per month. So I'm going to use this free tier, and under the features you can see what they are providing as a feature. So you can write your code, and you can use workspaces, you can use variables, runs, providers, modules, and you can deploy your modules into their public registry, and they have their spot plan. And I have already created my account, so let's just check that. So basically, this is the Terraform Cloud UI, and under that you have these projects, you have workspaces, you have registry where you can deploy your modules, and under setting you can create teams, users, you can create variable sets, and most important thing is which I am going to show you today about Terraform Cloud agents. So here is the agents tab. We can deploy Terraform agents, and we can then link our workspaces to those agents, and we can start deploying our code into multiple AWS accounts. So that's our agenda today. So the purpose of this Terraform Cloud is to run Terraform commands which we use to deploy Terraform code, such as Terraform init, Terraform validate, Terraform plan, Terraform apply. So all of these commands are run inside this UI, and we can see our plans in workspaces, and we can apply our plans on the workspaces. So I will show you in the later videos how the workspaces or projects UI look like. But today's our purpose is if somebody needs to use Terraform Cloud, so how he can or she can deploy Terraform agents. Although Terraform provides its own agents, so for example, you can see in the default execution mode, I can run my code onto the Terraform provided machines, or I can use my local machines, and I can see the runs and plans on onto the Terraform cloud, but my code is will still run, or the commands will still run on my local machine. And the third option is agent, which I am going to set up today. But instead of using this remote, we do not have control over those machines because they are running on Terraform platform. So if somebody needs to have more control over the machines, somebody wants to have more config in their machine, so we can deploy our agents, and those agent machines basically are running behind some VM, right? So that VM can be deployed in AWS or Azure or GCP as per the requirement. But I'm going to show how one can set up the agents machines into AWS. So let's start our demo. So I'm going to the code repository again. I have a Terraform AWS TFC agent repository here set up. So basically again some linting files, and here we have some TF files. So what I'm basically doing here is under the main file, I am creating a role for my machine because I'm going to create a EC2 machine on which my agent container will be running. So I am creating a role attaching some policies for CloudWatch logs and SSM system manager policy. I am creating a log group because I want to show my cloud agent container logs into CloudWatch logs and instance profile security group. And I'm going to create a auto-scaling group using this launch template. So so that my I can have fleet of instances span across multiple AZs. So for that, I have created this launch template, and this is the auto scaling group which is going to use the launch template and some tags. And this is the auto scaling schedule if I need to set up some scheduling actions on my auto scaling, when to turn off my EC2 instance, when to shut down or when to turn on again. So I can handle those kind of scheduling actions using this resource. So a very basic or simple file, the main.tf. Then I have written some other files, for example agent pool. So with the Terraform cloud, what you need to do, if you go to agents tab, you can see create an agent pool. So basically I'm creating this agent pool with the Terraform code, and I'm going to create a Terraform agent pool token which will be passed into the container machine so that they can registered in this specific agent pool. So this is the simple agent pool and token creation. Next we have cloud user data configure file. So in this file, what I am basically doing, I because I am going to run Terraform cloud container inside an EC2 machine. So for that, I have written some config files. So first of all, we have a Docker file for the Terraform cloud image, and Terraform is already providing us with the HashiCorp TFC agent image, which is available on Docker Hub, and one can run just agent container on local machine and using these commands. So, but for us to automate the process, I am going to write a Docker file, and I am installing some hooks directory. And the purpose of hooks directly I will explain a little bit, but this is the Docker file containing some commands. And then I have written a Docker compose file which will set up the Terraform cloud container, and it will pass some parameter, for example image, container name, environments variables, and then mounting the binding the volume. And then here you can see I am using logging driver AWS logs and passing the region and CloudWatch logs name, which I am creating here, the CloudWatch logs group. Yeah, so I'm passing that in a Docker compose file so that I can agent container can log into the CloudWatch log group. So this is just the simple Docker compose file which is running our TFC agent container. Now coming back to our these hooks directory. Here you can see we have this hooks directory. So what is the purpose of these hooks? So basically when in future I will show you in the later videos, when we will create a workspace, we will have these Terraform plan and Terraform apply stages. So each for each plan and apply stage, we need to configure hooks in Terraform agent configuration, right? So these basically what they are doing, they are when we run our code onto some workspace behind the scene, it will work with the workload identity structure. In the next videos, I'm going to show you that I will create a identity provider in AWS by which we can deploy our code into multiple accounts, AWS accounts, And these hooks are responsible to basically set up the credentials for multiple AWS accounts. Um, so I can also show you an image, a basic overview, because this is not our topic today, but let me just bring the documentation. So this is the documentation which is I'm talking about. So we have a Terraform cloud, we have cloud platform, which is in our case is AWS, and this is our TFC agents. So what these hooks are doing, basically they are setting up credentials. So instead of setting AWS access keys or secret keys, which are not recommended, right? What we can do, we can use workload identity structure of agents to generate short-lived and temporary credentials. So this is a way to do this. Basically, we have a token from Terraform Cloud inside our TFC agent. It will exchange this token with AWS identity provider and get temporary short-lived credentials. So to do all of this process, we have to set up these hooks. Um, right now, I just want to focus on the deployment of TFC agents, but I quickly want to show you what I have included in the files. So basically, these plan and apply hooks are required when we will in future videos see the workload identity structure and the running of actual code into our workspaces. So yeah, these are the hooked files. This is the Docker Compose file. This is the Docker file itself, and also you can see all of these documentation in Terraform Cloud page. So basically, they have written this documentation about how you can set up the agent hooks to perform um, plan and apply stages. So that's the whole documentation. What I have already shown you in my code. So yeah, this is the config directory, and next we have a user data. In user data, I have just I am building the Docker image for from this Docker file which we have seen here, and then I am replacing some variables in the Docker Compose files, and then I am creating a system D service for TFC agent container, and then enabling that service, right? So, and this is what I am doing in configure user data tf file, basically copying my Docker file to this directory, and for the pre-plan and pre-apply hooks, you can read the description. When we are using these cloud agents, we have to add these two hooks, right? The pre-plan hook will run at plan stage when we will have workspaces. So this hook will run and will communicate with OIDC, Open ID Connect provider, basically an identity provider in AWS, to get temporary credentials and store them inside the cloud agent machine, which is coming in later videos. So don't worry about that. um, so just cop this part is just copying this pre-plan and pre-apply hooks. Then I'm copying the Docker Compose file, and then the user data script. So first copying all of the files, then running the user data script, which will gonna build our Docker image and do some manipulation with the Docker file, and then create our container inside the EC2 machine. So we have seen the agent pool file, configure user data file. This is just data file, and we have a main file, some output, some variables, right? So this is our repository Terraform AWS TFC setup, which is going to deploy our agent machine in AWS and set up agent pool in Terraform Cloud, and then we can see our agent running in that agent pool. So yeah, let's deploy our code. So in the live demo, I'm going into live demo again. In the main file, in the previous demo, we have covered the creation of VPC and VPC endpoints. So right now, I'm going to deploy my TFC agents module. So this module is also available in my GitHub repository. Basically here, Terraform AWS TFC setup. So I'm just referencing that, and I'm setting this agent pool to my agent pool organization. So I have set up some variables. Here you can see I have agent pool organization as Einfach Cloud, passing some parameters for autoscaling group: minimum count 1, desired count 1, maximum 3. And I am passing the VPC ID, which is created by this module, and subnets. And here I am using an AMI. So this is this is my custom baked AMI. I have already installed AWS CLI and Docker into these AMI. I have done this via EC2 image builder pipeline or setup, but that's not a part of this demo. So I'm just saying, showing you that I'm using a custom custom baked AMI. You can also use an AMI which has already installed Docker and AWS CLI, right? So I'm passing the image ID, then the EC2 instance type, ABS volume types, and some ASG parameters. And this is the HashiCorp TFC image which I wanted to use. And this is the image version, some other environments. And this auto update is basically saying um, how you want to set up the auto updates. So in the documentation of TFC, under install and run agents, you can see here updates. So you can set it to minor, you can set it to patch, you can or disable this feature. So if I set to patch, the agent will only updates to the newest patch version, right? It is the semantic versioning, major, minor, and patch. So when I set it to patch, it will only update the patch. So yeah, this is just calling the module. And now let's go to this live repository and deploy our code. So Terraform init, Terraform validate, Terraform plan. So it has generated the plan. Let's see what it has generated. So it is going to create the auto scaling group, right? And it is going to create a CloudWatch logs group, and instance profile IAM role, which is fine. It is attaching the CloudWatch agent server policy and SSL managed instance core policy. And then we have a launch template with our EC2 configurations. And then we have security group, and then we have a agent pool and agent token. So let's deploy our code. So meanwhile it is deploying, let's just quickly review the architecture diagram. So I have created the architecture diagram. So this is basically just pretty much same which we have seen in our last demos. So we have VPC. In VPC we have these endpoints and availability zones, public and private subnets. So after our deployments, what going to happen? I have just expand my diagram. Under below you can see, so we have these availability zones and our auto scaling group. This auto scaling group is going to expand over these three availability zones and these three private subnets. And this auto scaling group is going to deploy a fleet of instances in any of these private subnets or availability zones. right? So this is just a basic demonstration of how the autoscaling will gonna look like in network diagram. So our resources are added. Let's just log into our account and check under the EC2 tab. We will see probably our agent machine. Yeah, so here you can see our agent machine is initializing demo TFC agent cloud and fog cloud, and it is the t3 dot small. And we can also probably log into this machine using session manager, because right now how this is possible, because we have already deployed VPC endpoints, right? So these SSM messages or EC2 messages or SSM VPC endpoints are enabling me to log into these EC2 machines, and the request will gonna go through our endpoints which we have deployed, right? So it is not going to use the internet route, but it is going to use the VPC endpoints route to SSH into our EC2 instance. So you can go to session manager, you can connect, and under that you can check how's your deployments going. So if I will run docker ps, my container is not set up. Let's check the logs of our cloud init group. So probably our cloud agent machine is set up. Let's just tail our logs. So probably it is done. Let's just again docker ps. So yeah, you can see on our EC2 machine, a container is set up, which is named as demo TFC agent infra cloud. And this agent is basically set up via this docker compose file, which is copied via the Terraform code in this directory. So you can see this docker compose file here, and under the configurations file we have some hook files which we have seen in our docker file, right? So right now our EC2 machine is set up and a container is deployed, and now let's check what has happened in the Terraform Cloud UI. So this is our UI. If I will go to refresh the agents tab, yeah, you can see that it has created the demo TFC agent infra cloud agent pool, and under this agent pool, my agent machine is now registered with this ID. And right now it is in idle state because we do not have any workspaces running on this agent pool. And if I click on this agent pool, you can see under the tokens, which is generated also by Terraform code. And when we will have workspaces in our organization, they will be registered under this agent pool, but that's a later step. The right now the purpose of this demo is to show you how to set up an agent machine in AWS cloud, and how its registration is done via the TFC cloud UI. So yeah, this is the demo. So you can directly use my code repository, which is Terraform TFC agent repository I have shown you, to directly deploy your to directly deploy the EC2 machine into AWS cloud. Right now it is written for the AWS cloud, but I will expand it to other multiple cloud, for example Azure or GCP. So you can directly clone it and deploy the agent into your AWS account, and create a Terraform account, and then see how the registration of agent pool and agent gets done. And in the next upcoming videos, I am going to show you how this workload identity basically works. how we can now use this agent to deploy Terraform code or Terraform resources into multiple AWS accounts, not a single AWS account, but multiple AWS. So that will be coming in future videos. Thanks for watching. Stay tuned.